Hello, everyone. On this podcast episode, I'm gonna try to explain, a black hole again. Using a magnet because I know scientists are stuck, trying to figure out how a black hole works. So I'm gonna use a magnet and the law of duality to explain, you know, how a black hole works. A black hole works just like a magnet, and a magnet follows the laws of duality. A magnet, there are things a magnet can attract. There are things a magnet can repel. Because there are things a magnet can attract, a magnet must also be capable of repelling. Because this is how duality works. Both states must exist simultaneously as one. So if a magnet can attract things, right? A magnet must be capable of doing the equal and opposite, repelling things as well. And since a magnet can attract things, right? A magnet can also repel things. Because these two states must exist simultaneously as one. And since a magnet can both attract and repel things, right? Then there are things in this world that a magnet should never be able to attract nor repel. Because a magnet can attract or repel things, its equal and opposite must also be true. There must be things in this world that a magnet can neither attract nor repel. And that's how a magnet works. A magnet follows the rules of duality. There are things in this world that a magnet can attract. If you put iron in front of a magnet, it will be pulled towards the magnet, or the magnet will be pulled towards it. If you put the negative end of one magnet towards the negative end of another magnet, right? These two things will repel. They'll repel each other, right? If you carry a magnet and hold it in your hand, you will notice something. A magnet can neither attract nor repel your hands. Because the magnet must follow the laws of duality. All equal and opposite states must exist simultaneously within the magnet. And that's how the sun works. There are things the sun attracts. The sun attracts things with mass. And the sun repels energy. The sun repels light. Just as the sun is attracting objects with mass, the sun is repelling electromagnetic waves from itself. So the sun works just like a magnet. And because the sun can both attract and repel objects, right? Then there are objects in this world that a sun can neither attract nor repel, just like the human hand. Just like the human hand can grab a magnet without feeling any repulsion or attraction to it. There's something in this world that can neither be pulled by the sun nor repelled by the sun. And that's the way a black hole works too. A black hole must follow the same law as a magnet. If a black hole is capable of pulling something, a black hole must also repel something at the same time, just like the sun. And because we don't see what a black hole repels, a black hole must, there's a high chance a black hole is repelling dark energy. It is sucking in energy and repelling dark energy, just like the sun sucks in mass and repels electromagnetic waves. It repels massless objects. It repels massless energy. And because a black hole works just like the sun, there are objects in this world, there are things in this world that a black hole can neither attract nor repel. But we don't know what that is. Scientists are stuck seeing things from one point of view. They see a magnet and they only see, when they look at the sun, they see the sun just like a magnet. They only see the things the sun can attract and repel. They see the mass going into the sun, and they also see, electromagnetic waves escaping the sun. But they don't see the equal and opposite of that. They don't see where this, they don't see the objects that the sun can neither attract nor repel. Because no one, the sun is too dangerous for us to be making experiments on. But there are objects in this world. Just like a magnet has objects that it can neither attract nor repel, there are things in this world that the sun can neither attract nor repel as well. And there are also things that a black hole can neither attract nor repel. And that's how this universe works as well. This universe follows the same rule as a magnet. Many scientists do not believe the universe has an edge or a center. But if you follow the laws of duality, because the universe does not have an edge or a center, its equal and opposite must also be true. From the perspective of scientists, the universe does not have an edge or a center. But because that perspective exists, its equal and opposite perspective must also exist, just like a magnet. Some people only see they only see a magnet as something that attracts things. Because they only see a magnet as something that attracts things. It doesn't cross their mind that a magnet is also capable of repelling things as well. Some scientists only see, the sun attract and repel things. But it doesn't cross their mind that the equal and opposite is also true. There are things in this world that, that the sun can neither attract nor repel. And that's true with a black hole and the universe. Scientists only see what a black hole can attract. They don't see what a black hole can repel. Because they don't see what a black hole repels, they assume a black hole does not repel anything. For a black hole to attract things, its equal and opposite state must also exist. The black hole must also be repelling things at the same time. And there is something a black hole repels, because it has to repel something. Because all states must exist simultaneously within that black hole. If a black hole is capable of attracting objects, a black hole must also be capable of repelling objects as well. And then a black hole, then there are objects in this world that a black hole can neither attract nor repel. And let's go back to, the universe as a whole. Scientists do not see the universe as a place with a center, right? But because of that, the equal and opposite state must also exist. Because scientists cannot find the center or the edge of a universe, it proves that the universe has a center and an edge. The equal and opposite state must also exist. Because the world appears, if you look at planet Earth, it appears flat. But just because the world appears flat, if you're standing on Earth, the world will always appear flat. But just because your place flat does not mean it's flat. Just because your eyes does not see the Earth curve does not mean the Earth doesn't curve. Just because the scientists cannot find the center of the universe does not mean the universe doesn't have a center. Just because the scientist does not find the edge of a universe does not mean the universe doesn't have an edge. There's a likely reason why scientists can't find this, the center or edge of a universe. Is because the universe is inside a larger universe. Because if one universe can exist, multiple universes, it's equal and opposite. Multiple universes must also exist. The possibility of multiple universes also, exists as well. It means the moment one exists, many can also exist as well. The fact that we know that one universe exists proves that multiple universes can exist as well. The equal and opposite must also exist. The equal and opposite of one is many. If you find one, you'll be able to find many. If you find one car, it proves that multiple cars can exist. If you find one house, it proves that multiple houses can exist. If you find one planet, it proves that multiple planets can exist. If you find one planet with life, it proves that multiple planets with life can exist. If you find one atom, it proves that multiple atoms can exist. If you find one universe, it proves that multiple universes, can exist. And the reason why, there's a the likely reason why scientists can't find the edge or the center of the universe, like I said in other episodes, is because this universe is inside a larger universe, which is inside a larger universe, which is inside a larger universe. Because this universe is inside a larger universe, scientists cannot tell where this universe ends and where the other universe begins. Because scientists cannot tell where this universe ends, they can't find the center. Because you must first know where this one ends first. You must first be able to find the edge of something to know where the center is. If you can't find the edge of something, it'll appear as if the thing doesn't have an edge or a center. So the only reason scientists believe this universe has no center or no edge is because they can't find the center. And the likely reason why they can't find the center is because the center and the edge blend in with the larger universe, which blends in with the larger universe, which blends in with the larger universe, and goes on and on and on. Because if one universe exists, multiple must also exist. And this is how this world works. One creates many, many creates one. Within one universe, there are many universes. And that's how this world works. This universe has many universes within it, but we don't call them universes. We call them galaxies, we call them planets, we call them solar systems. And the smallest universe is we don't even call that a universe. We call it an atom. An atom looks, if you look at the diagram of an atom, it looks just like a solar system. It looks just like a solar system. But because it's so small, it doesn't, we don't classify it as a universe because it's too small. Many people think because the universe expands, right? And solar system shrinks. The solar system gets smaller and smaller, falls into the sun. They don't realize that's how the universe works as well. The reason why the universe is expanding is because dark energy is being pulled into the universe. The fact that the universe is stretching, right, or expanding, proves that something must also be contracting. These equal and opposite states must exist simultaneously as one. Just like the sun and just like a magnet. If something's being pushed away, something must also be pulled. As the sun pushes away electromagnetic waves, it pulls in objects with mass, energy with mass. As a black hole pulls in all forms of energy, it pushes out, it repels. It likely repels dark energy, because dark energy is the only energy that we can detect. Scientists can detect dark energy. So that's why they keep believing that a black hole doesn't, release any form of energy. But it has to, because it has to follow the laws of duality. The laws of a magnet. It must behave like a magnet. If something is being pulled, something must also be, capable of being repelled as well. A magnet attracts, a magnet repels. And then magnet also neither attracts nor repels. The sun attracts, the sun repels, and the sun neither attracts nor repels. A black hole attracts, a black hole repels. A black hole neither attracts nor repels. The universe attracts, the universe repels, and the universe neither attracts nor repels. There are things in this universe that can't be attracted nor repelled by the center of our universe. But the center of our universe exists. We just can't find it. And the likely reason why we can't find it is probably because it is filled with dark energy. Why? Because as the universe expands, right? Scientists have figured out that, they notice that as the universe expands, dark energy keep accumulating within the universe. Why do you think that? Why do you think that is? Is because outside of our universe, in the larger universe, right, is filled with dark energy. As the dark energy outside of the universe comes in, is being pulled into our universe by the center of our universe, right? Our universe is being pushed out. The objects and energy within our universe is being pushed out and being replaced by dark energy. So our universe will take the place of of dark energy, and dark energy will take the place of our universe. Dark energy is accumulating within our universe for a reason. Is because it's being attracted to the center of our universe. Our universe is being pushed out for a reason. Because dark energy is pushing us out. We get pushed out and dark energy gets pulled in. And there are things the center of our universe can neither attract nor push out. I don't know what that is, but it exists. Just like there are things in this world that a magnet can neither attract nor repel. There are things in this world that the center of our universe can neither attract nor repel. Our universe is repelling us. The center of our universe is repelling all energy, all forms of energy, and it's attracting dark energy. And because we live in a massive universe, which is inside a larger universe, we can never see the edge of our universe. Because the edge of our universe blends in with the beginning of the larger universe. Just like, the edge of our solar system blends in with the rest of with the rest of the universe. If you truly study it, you never truly tell where the end of where our solar system truly ends. The asteroids, you may think it ends at on Pluto, at Pluto, but that is just the last planet. There's still little asteroids and small little particles still revolving around the sun outside of Pluto. We don't call them planets, so we don't count them as part of our solar system. But those things still exist, and they still count as part of our solar system. As long as they revolve around our sun, they still count as our solar system. At some point in time, we'll never be able to tell where our solar system ends and where another solar system begins. And this is how life works. It's hard to tell where our solar system ends and where another solar system begins. Because, the gravitational pull of the sun is very large. It could extend to a different, solar system. It is very large. It goes beyond Pluto. We call Pluto the end of our solar system, but it's not. The end of our solar system is where the sun's gravitational pull stops. And we truly don't know where that is. We have a guess where it is. But we don't fully know where it is. So where does our solar system start? No one knows. But because we've already created, we believe it stops at Pluto. That's why, we use Pluto as the edge of our solar system. But we're just guessing that Pluto is the end. The truth is, Pluto is not the end of our solar system. But because we use Pluto as a benchmark, we can finally we can figure out that the sun is at the center. But is the sun really the center? Nobody knows. When you can't find the center of something because it's too large, right? It's too large and vague. It's hard. If you can't find the edge of something because it's too large and vague, it's hard to find the center. It's hard to find the center. But if you follow the laws of duality, because the world appears to not have a center or an edge, it means that its equal and opposite must be true. The world must have a center and an edge. Because a magnet is both positive and negative, it means a magnet is also neither positive nor negative. Because a magnet is neither positive nor negative, it proves that a magnet is both positive and negative. The fact that the moon is neither positive nor negative proves that the moon has both positive and negative waves inside of it, both positive and negative charges inside of it. These two opposites must exist simultaneously as one. The world, the universe has an edge. Scientists can't find it, you know, but just because scientists can't find the edge does not mean it doesn't exist. You know, just like, flat earthers. They see the world as flat, but just because you see the world as flat does not mean the world is flat. You know, everything follows the laws of duality, just like light does. Light is a particle and also a wave. Light is one and also many. It is one continuous wave, and it's also many tiny little particles. And because light is both a particle and a wave, it is also neither a particle nor a wave. But scientists can only see it as a particle or a wave. We can't see the other state of it. We can't see where it's neither a particle nor a wave. But since light is both a particle and a wave, right? It means its equal and opposite must also be true. There's a third state in light where it's neither a particle nor a wave. But we haven't found that state yet, so until we find that state, scientists will believe it doesn't exist. Back in the days when scientists believed, light was a particle or light was a wave, right? Well, when you see only one perspective, you think the other perspective doesn't exist. But because one perspective exists, its equal and opposite must also exist. Because the earth appears to not be moving, its equal and opposite must also exist. It means the earth is always moving. Because the earth is always moving, its equal and opposite must also exist. The earth is never moving. When you're standing on planet Earth, you will never feel it move. Yet the earth is always moving. When you look outside of you, when you stand on the moon, you always see the earth move. Because the earth is always moving, it means the earth is also not moving at all. Perspective determines whether the earth is moving or not. Perspective determines whether light is a particle nor a wave. Perspective determines whether a magnet is positive nor negative or negative. Perspective determines whether the sun is attracting or repelling an object. Perspective determines whether a black hole is attracting or repelling an object. And perspective determines whether the universe has an edge or does not. Perspective, perspective, perspective. This world is a world of duality. And the world of duality follows perspective. From one perspective, the earth is not moving at all. From another perspective, the earth is always moving. From one perspective, the sun is very hot. From another perspective, the sun is very, very cold. From the perspective of something hotter than the sun is cold. From the perspective of humans living on planet Earth, the sun is very, very hot. From the perspective of humans living on Earth, the Earth isn't that hot. From the perspective of someone living on the moon, the Earth is very, very hot. It is warm. It is warmer than the moon, And, from the perspective of, someone living on a planet that's filled with, ice, right? The sun, the Earth is probably just as hot as the sun. It's too hot, from their perspective. From the perspective of something very, very cold, like a cold planet, Earth is very, very hot. And this is how life works. Life follows perspective. And both opposites must exist simultaneously as one. If one perspective is true, its equal and opposite must also be true. So that's it for today's podcast episode. I'll talk to you guys later. Bye.